Good afternoon, everyone. This is Meghna Bhatia, Assistant Professor, SIS College of Science, Arts and Commerce, Navi Mumbai. The research presentation topic is e-learning platform security issues and vulnerability analysis. The basic content which I am going to go through is introduction, e-learning security, methodology, results, and final is the conclusion. We start off with the introduction. Having added more and more organization offering these online courses, information security is becoming an important issue not only for education sector but also for other organizations too. It is the user friendliness, all the time 24/7 availability, and ubiquitous of web applications have made them vulnerable. It is also the unpretentious fault implementation in the application which again allows the invader to steal the sensitive information and perform advisory actions which can cause threat or attack to the system. So, there's a need for defensive mechanism for securing web applications from the flaws which are now receiving the attention not just from the academic side but also is a requirement for industry too. There is comprehensive research in the literature about the evaluation of e-learning software platforms, their basic features, usage, capabilities, and the concerns and effectiveness. But contrary to the above, there's hardly any research or very few research which is done with respect to the security and the privacy issues or addressing those issues relating to the LMS and e-learning products. The 6 basic principles of security are authenticity, access control, confidentiality, integrity, availability, and non-repudiation. The most important or rather the important factors of e-learning system usage are, naming few, are awareness raising, protection of data, single sign-on, seamless access, digital rights management, anonymous usage, and authenticity of learning resources. The main methodology used for the above paper has been divided into 3 sections. The first section is focusing on the software vulnerability taxonomies. The second part is the vulnerability scanner used for the same purpose, and the third part is the open source e-learning platform which has been selected, or rather the 15 open source e-learning platforms which are selected among the available platforms. From the above evaluation, it includes, or rather it says, conveys the analysis of the vulnerability which has been found, their classification and their severity has been reported. Along with that, the overall evaluation and the impact of potential dangers of the vulnerability which has been reported, and at least the security scanners have been evaluated in a scientific way which are basically used for the same purpose. So out of these 3 sections, the first section which talks about security vulnerability taxonomy is the taxonomy which is mainly accepted or rather widely used by, on the basis widely accepted by the organizations which are mentioned below, like CWSS, which is Common Weakness Coding System, OWASP, which is an Open Web Application Security Project, CAPEC, which is a Common Attack Pattern Enumeration and Classification, and more focused about the web concern threats. The organization is Web Application Security Consortium. The above mentioned all the communities are addressing the needs of stakeholders and are giving the list of errors and vulnerabilities present in the systems. Not only that, they are also mentioning the different patterns of attacks which are employed, their adversaries or adversity, and how these attacks can be used or exploited because of their known weakness. Not just this, they are also used to understand the best practices or the standards which are mentioned by the above text. Based on these taxonomy, the standard has been defined. The second part is vulnerability scanner, where the two well-known scanner has been selected, NetSparker and Accutenix. The reason for selecting the two is they both have good level of explanation given to the vulnerabilities or about the vulnerabilities which are found. They are user friendly, they are considerably fast, and they don't require any specific setup. They have very well-known market and they score very high in terms of extensive test. They both provide free edition. The third section is the open selection of the open source e-learning platform. So out of dozens which are available or hundreds which are available, the 15 LMS or rather the e-learning LMS were selected based on the popularity, based on their ranking, based on the usage. The findings from the above research is the finding is try to homogenize the results of those softwares those different scanners in order to homogenize and to present them in a uniform way and to have an acceptable result. We cannot squeeze the entire parameters under a common label. So rather doing that way, we have divided the section into three different parts, wherein the first part is about checking the vulnerabilities found per platform per scanner, where both these scanners were tested for all 15 LMS and the results were shown. And in the second part or in the second graph, it is all the 15 have severe vulnerabilities which were found per platform were reported, and whereas in the third classification of weakness, the top few or rather the severe vulnerabilities which were found and which were common in the both were reported, where the common were calculated based on if both scanner if they found the same vulnerability, the count is 1. But if one of the scanner on a specific platform also found this, then it is also considered to be 1. So not just this, not all vulnerabilities are common for both scanners. So there is a set of super category was also formed, where we've tried to present the result in all three graphs which are given. Based on this classification which was been done, then further was the proposed model for ensuring the security in e-learning platform, where there were two approaches which are being presented. One is hierarchical approach. Hierarchical holds the system administrator at the top tier of the control structure, and it then permeates to the instructor and then to the pool of learners. to study, or rather to restrict the resources and control them primarily by the sole administrator and then coming down to the instructor. That's an hierarchical model which start off or which has an initiation by the admin, and then it goes to the second level, which is instructor. This is channel, and then from there it goes to the learner level. The second approach is distributed approach, which is contrary to the centralized approach in enforcing the security over the e-learning system. There's a distributed approach and a separate structure for it. In distributed structure, it keeps a separate security model for each of the element in the e-learning system. The main advantage over the hierarchical system in the distributed approach is it is more scalable in terms of numbers, and it is never a bottleneck to add or subtract number of users in this. At the end of, by proposing this, the entire security model can be structured based on certain timelines where there are certain objectives and phases which are defined at the end of this. The first objective could be framing of security policies for e-learning system. The second phase would definitely cover the implementation of the security models within the e-learning system. The third phase would be employing a constant monitoring system which can detect an attack, or when we talk about eavesdropping. The fourth phase is SOS phase, which mainly needs to be invoked when in case of any attack. The main task in this phase is again divided into two subfolds. First is to safeguard maximum portion of the system or the resources, and second is to set right the damaged things along with stringent action against the attacker. At last, I would like to conclude my session by saying that it is the omnipresence of web application and e-learning tools which makes it important to ensure that the tools are secure, correct, and efficiently used. There cannot be any final score which can be assigned to any platform which has been tested, nor we can structure a table with a platform tested in an ascending order based on any such criteria, since there is no widely accepted tool or technique available today that assigns. Rather, we can say in the above analysis there were few platforms which were more weak than the rest, since they seem to have more recognized vulnerabilities than the other applications. I would say at the end that academia and the industry needs to understand the importance of security aspects of the e-learning tools and softwares, which may help the researchers and the programmers to design a better level of product. And at the end, I would say the main aim of opening this discussion was how to conduct a security evaluation on the application, and also to provide a kind of guide to follow so that we can finally design a system which is more error free or threat free, or which is not very prone to such kind of attacks by taking certain preventive measures. By this, I would like to conclude my session. Thank you so much. Good day.